The magic of the internet. Have you ever wondered how exactly the internet works? What happens when you type in a URL in your browser and hit enter? How do all of these things function under the hood? Well, let me tell you. The answer to these questions lies in understanding how computer networking works. So, how can we define a network? To put it in simple terms, a computer network can be defined as two or more computers connected by some means through which they are capable of sharing information. In a similar way, we can define the internet as a computer network that connects billions of computing devices throughout the world. Before understanding this amazingly large and complex system, we first need to get our fundamentals clear. So, in this session, we will learn all the basic terminologies and concepts that will help you get started. The topics which we are going to cover in this video are components of data communication, direction of data flow, types of communication, categories of network. Now let's look at the components of data communication. First, the message. The message is the information, data to be communicated. It can be a text, numbers, pictures, sound, or video. Next, the sender. The sender is the device that sends the data or the message. The receiver. The receiver is the device that receives the message. And the medium. The transmission medium is the physical path by which a message travels from sender to receiver. It could be wired or wireless. For all this to work effectively, we need a set of rules, and this is called the protocol. A protocol is a set of rules. It represents an agreement between communicating devices. Data communications. For the sake of sharing information, communication needs to take place. Communication between individuals occurs face to face, whereas communication between devices takes place via some form of transmission medium. This exchange of information between two devices is called data communication. For effective data communication, the system must deliver the data to the intended receiver. Delivery. The data delivered must be accurate, accuracy, and must be reached on time. Timeliness. Now let's try to understand how all these components come together and form a network. Consider, for example, a factory that needs to move a large amount of cargo to some destination warehouse located thousands of kilometers away. At the factory, the cargo is segmented and loaded into a fleet of trucks. Each of the trucks then independently travels through the network of highways, roads, and intersections to the destination warehouse. At the destination warehouse, the cargo is unloaded and grouped with the rest of the cargo arriving from the same shipment. Thus, in many ways, the factory, you could say, is like the sender, the warehouse is the receiver. Messages are analogous to trucks, and communication links, mediums, are the highways and roads. Just as a truck takes a path through the transportation network, a packet, the message, takes a path through a computer network. Direction of data. Flow simplex. In simplex mode, the communication is unidirectional. That is, data flows in only one direction. Only one of the two devices on a link can transmit. The other can only receive. Example, keyboard and traditional monitors. The keyboard can only introduce input. The monitor can only give the output. Half duplex. In half duplex mode, each station can both transmit and receive, but not at the same time. Walkie-talkie is a typical half duplex device. It has a push-to-talk button, which can be used to turn on the transmitter, but turn off the receiver. Therefore, once you push the button, you cannot hear the person you are talking to, but your partner can hear you. Full duplex. In full duplex mode, both stations can transmit and receive simultaneously. Take telephone as an example. People at both ends of a call can speak and be heard by each other at the same time because there are two communication paths between them. Thus, using the full duplex mode can greatly increase the efficacy of communication. Types of connection. Point-to-point connection. In point-to-point connection, a dedicated link is provided between two devices. In this communication, there is one transmitter and one receiver. For example, when you change television channels by infrared remote control, you are establishing a point-to-point connection between the remote control and the television's control system. Multi-point connection. A multi-point connection is one in which more than two specific devices share a single link. In this communication, there is one transmitter and many receivers. Let me give you an example which you are familiar with. Multi-point connection is like a broadcast network. In a broadcast network, the packet transmitted by the sender is received and processed by every device on the link. But by the address field in the packet, the receiver determines whether the packet belongs to it or not. If not, it discards the packet. If packet belongs to the receiver, then it keeps the packet and responds to the sender accordingly. Categories of network. LAN, local area networks, generally called LANs, are privately owned networks within a single building or campus of up to a few kilometers in size. They are widely used to connect personal computers and workstations in company offices and factories to share resources, example printers, and exchange information. MAN, a metropolitan area network, or MAN, covers a city. The best known example of a MAN is the cable television network available in many cities. WAN, a wide area network, or WAN, spans a large geographical area, often a country or continent. It contains a collection of machines intended for running user programs. When two or more such networks are connected, they become an internet work or internet. I'm sure you now have a better understanding of data communications.